Hey all, and welcome to the last week of going over things from Calculus 1. I sent out an email, and there's also an announcement in the stream regarding this, and I would love to have you fill out the survey that's attached for today's check-in to figure out a time that we can all meet and what makes the most sense for us to discuss your first exam that you're going to take regarding your Calc 1 materials, and exact timing for that is going to be before Thanksgiving break, so in a few weeks. Now, before we move on to full discussion about the test, though, there are still 3 topics this week, and we're going to talk about the first one right now. So get yourself ready for notes, and let's get started. So find the average value of a function. Now, if you remember this from previous classes, the idea here is that if I have a function here, f of x, then the average value, it goes higher here, it goes lower. There's the average value, which is this. And the idea there is that the average is the sum divided by how many numbers you have, divided by the interval. So the sum of all of the different values of the function is the value of the integral. And the interval would be from, in this case, a to b, so b minus a. And you'll often see the average value then written as 1 over b minus a times the integral instead of dividing it like so. Now, for number 1, it says find the average value of f of x equals ln squared of x between x equals 2 and x equals 4. So the first thing you want to do is set up the integral, and so we end up with 1 over 4 minus 2 for b minus a, and then the bounds from 2 to 4 of the function, and ln squared of x dx. Now, you don't know how to take this integral yet. This is something that we're going to do in Calc 2 materials. So let's do a quick review of how to use your calculator for definite integrals and practice that if you haven't already. So what you want to do, for most of you using graphing calculators at home, you're using the TI. So remember, you want to go to the math button and then go down until you see FN int for integral. Now, some of them you're going to be able to fill in just like this, and you're going to end up wanting to type this integral in as from 2 to 4 of parentheses, ln parentheses x, close all those, squared, dx. However, some of your older calculators won't let you type them in function form, and so you're going to then type in the function first. So parentheses, ln parentheses x, close the parentheses, squared. Then comma the variable x, comma the 2 bounds like so, and then click enter. So whichever way your calculator will let you do that, the answer for that integral area is 2.409, and then don't forget we're still multiplying that by 1 over 4 minus 2, which would be 1 over 2 both times. And that is then equal to 1.205. Hopefully you aren't having calculator problems. If you are, please let me know. Now, with average value, you also are going to have things about the mean value theorem of integrals. So remember, there's one for derivatives that says that there's a tangent line parallel to any secant line. Here, the mean value theorem of integrals says that if f of x is continuous on the interval, then there is some value of the function that's equal to the average value. So if we're looking at the picture up here, that this average value crosses the function at least one place. So there exists at least one c. And so what a common question would be is find the value of c that satisfies the mean value theorem for integrals using the function above. So what you'll do then is you are going to set the function equal to the average value. So the function in this case of f of x is ln squared x and is equal to the average value, which we just found above as 1.205. And yes, obviously that's the rounded answer. Now what we want to do is solve for this variable here. So if you want to, you can even substitute that as the c, like so. Now if I'm solving for c, the first thing I'm going to do is take the square root of both sides, and that gives me ln by itself is equal to, I'm sorry, just using my calculator off to the side here, square root of 1.205, which would be, and again, rounding it to 3 digits, 1.098. I'm rounding it on my paper. I'm not rounding it on my calculator. I should clarify. Then to get c by itself, raise them both to the power of e. And then you end up with c is equal to 2.997, which does ask me, the question is that if I rounded, which I did round right here, if I hadn't rounded, would this answer end up being 3? And that's always an important thought to have when you just have an answer this close to a number. Same thing when your calculator is occasionally trying to find roots, mins, maxes, you'll end up with something like negative 0.000001. It probably just means 0 and your calculator's not quite accurate enough. So that's something always to think about, especially if you're looking at a multiple choice. If I saw 3 as an option and this is what my calculator spat out, I'd be like, you know what, I probably rounded at some point, or my calculator was a little bit weird at this operation, and that's where that issue came from. If you have questions about the mean value theorem or about average value, please let me know, and I'll talk to you later.